In this video, I am going to continue discussing our reactions of alcohols, and in particular, I am going to discuss dehydration reactions and ether formation reactions. And so the dehydration reactions are ones that I've already discussed in the videos on alkenes, and the ether formation I will be discussing more in the videos on ethers. So this one is going to be fairly quick here. So again, the dehydration reactions of alcohols look like this. So we will protonate this by having that grab a hydrogen from there. This becomes a water leaving group, and we can do an elimination reaction to form our alkene here. And we can drive the reaction towards products by removing alkene through distillation, so using Le Chatelier's principle to drive the reaction towards the products. And this works since the alkene products tend to have a lower boiling point than alcohol reactants, and so we can actually do a distillation to remove alkene product. And so this is usually done through the E1 mechanism, and so we want the carbocation to be as stabilized as possible. And so that means having tertiary carbocations is going to be a lot better than primary. And so the rate decreases as we go from tertiary to secondary to primary. With primary alcohols, we get a lot of rearrangements and isomerizations, and in fact, this is so common that acid-catalyzed dehydration is rarely a good method for converting them to alkenes. So the rearrangement we have is we're forming this right here, which can leave as a water. This gives us a primary carbocation. So this hydrogen is likely to move over there so that we can get a more stable secondary carbocation. And so that's what we end up with here. Then we can have water come in and do an elimination on one of the neighboring hydrogens. And what we're going to see is that we will mostly get the Zaitsev's product. So that would be, in this case, the 2-butane or 2-butene. And so we can get that, and that'll be about 70%, and the 1-butene would be 30%. And so we end up getting a mixture of these two products when we try to do the dehydration using a primary alcohol. And we can think about what would happen as well if we try to do this with a diol. So that means we have two alcohols on here. So if we look at that, we have two alcohols on here, and this is called the pinacol rearrangement. And we have pinacol here, we put in our acid, we heat it up, and we get this pinacolone, which is the ketone version of this. And so what's going on is we have this alcohol here comes and grabs an H+, so we end up with this leaving group, which will leave, and so the electrons go there. We end up with this carbocation here. This methyl group will shift over to there, so that we end up with this right here. This can then be resonance stabilized, and we can have the water come in and grab that hydrogen right there, so that we end up with our ketone on here. So we end up with the pinacolone right there. And so switching gears, now we're getting away from the dehydration, and we are now looking at ether synthesis, which, like I said, in future videos when I talk about ethers in particular, I will discuss this more again. And so we saw in an earlier video that if we want to make an alkoxide, we can add sodium or potassium metal, the potassium being better if we are looking at a tertiary alcohol. So some alcohols are slow even with the potassium, so we can just use NaH, which is that hydride. It's a very strong base, and we do this in tetrahydrofuran, and so we can again form our alkoxide here. So the alkoxide ion is a strong nucleophile and powerful base, and this can be reacted with primary alkyl halides and tosylates to form ethers. So we have our alkoxide here. This will come and attack that carbon there. This halogen will leave, and so we end up forming this ether right here with the halide as the leaving group. So the alkyl halide or tosylate must be a good SN2 substrate, and so it is usually primary. We therefore want to choose the less hindered alkyl group to be the substrate and the more hindered group to be the alkoxide ion. And so if you are taking a sophomore level organic chemistry class, you'll probably be given problems where it will be something like this, where we have our alcohol right here, and so this will have two R groups plus our alkyl halide, which we can have right here with maybe one R group like this. This should also have a hydrogen right there and like that. Or it will ask you if we could have instead this with the R groups right there and the halogen right there plus our alcohol like this. And so it will ask you which one of these is going to be better. And since we want the least hindered one to be the substrate or electrophile, what we will choose is to have this one be the better reaction right here. So in both cases, we're going to be making the same ether, but we want to choose to have the electrophile or the substrate to be the least hindered one. So we would prefer to put that onto the primary here rather than have the alcohol on the primary right there. So if the substrate is secondary or tertiary, we get a lot of E2 occurring instead of SN2, and so we get a lot of side reactions. And so this is the reaction we're talking about. So remember, we have our more hindered molecule here being our nucleophile and the less hindered one being the electrophile. So we have this come in, it attacks that carbon, this bromide leaves, and we end up with this ether right here. And another way we can form ethers is what's called bimolecular dehydration. So in acidic conditions, we can do SN2 on primary alcohols to form ethers. So we have this primary alcohol right here. We bring in another one of our alcohols right here. This will attack that. This leaves as water. And so we end up with this right here. We can deprotonate this with just another alcohol. And then we end up with this right here. So we can make diethyl ether this way. And so those, as I said, are ways we can use alcohols to produce ethers. I will talk about those more in future videos on ethers, but these are two strategies to make ethers using alcohols. But anyway, that was everything I wanted to talk about in this video. I hope you found that useful, and I will see you in the next one.